Now today we are going to learn R, okay?
Okay.
So one of the good things about R is it's easy for you to generate figures. Like for example, if you want to generate a figure to show your height. Let's say when you go to see a doctor, right?
Yeah.
Your doctor will measure your weight, your height,
Yeah.
and your the side of your head, right?
Yeah.
And then every time you go, the doctor will ask you, and then the doctor will show me a graph, a figure to show okay where you are at on the figure, to see compared to the all the kids they have.
Okay.
Whether you are on the average. What is the average? Do you know what is the average?
No.
So let's say when you see average, when you hear people say average or say mean, basically, okay, let's say how to calculate the mean or the average. The most widely used method of calculating an average is the mean. When the term average is used in mathematical sense, it usually refers to the mean, especially when no other information is given. Okay, what is mean? Mean here mean doesn't mean you are rude. It just talks about the data or description of the data. Okay, let's say when you have okay, let's open RStudio. Let's imagine you have lots of students. How many students do you have in your class?
Students, 22.
When we say students, right? And then you can say student height. And you say oh, and you say you want to have a variable. This is the variable called student height in R. And then you say, okay, how many students do you have?
22.
22, okay. That's too many for me. But let's imagine you have 10 students.
Okay.
And each of them, how tall are you? Do you know?
Tall, no.
Maybe 65 inches?
Okay, 65.
Okay. Let's see how tall is the...
What are you gonna do?
I'm just going to how tall is
Angela?
6 years old girl. Let's say average, on average, what is 6? Oh, okay. Let's say you have
Oh,
you are 77 years old and you are 47.7
I'm 6
inches.
years old.
Almost 7. Okay?
Okay.
Let's take this one. And then I will use this just to get some pseudo number, like random number I can think of. Let's say some people they are, let's say you are 47.7 inches and the other person is the 50, maybe taller than you, and the other one is maybe 45, and the other one is maybe can you give me a number? 52.
Okay.
And then the other one is maybe 22 is too short as a person.
Okay.
Let's say just something around, let's say 16, maybe very tall, and maybe 48, and maybe 49. Oh, sorry, 40.
56.
Oh, 56. Okay,
56.
56.
Fif-
How many do we have now? 1, 2, 3, 4, 5, 6, 7. And maybe 3 more. And 48 again. And 45 again. And 40, let's say 62. Maybe this is very tall. This guy is very tall, right? And now when I say, okay, what's the average? What's the mean of the student's height?
Oh.
Okay. What we can do is when we say, let's say we have two students. If we just imagine we have two students. Oh, let's say what's yours and Sarah's height? Let's say your height is let's say 57 plus Sarah's height, which is maybe 39.
It didn't come out.
Here, it comes here.
Oh, okay.
So the total is what? Total is 86, right? You just use 80, 47, 39. That the total is 86, right?
Yeah.
And what's the average or what's the mean of your heights? Like yours and Sarah's. Then we just divide it by 2, right?
Yeah.
But just split it into 2 parts. That's the average, right?
Yeah.
So, and then when we do this in the programming language, we just do it like this. Use bracket, and then backslash means division, and then divide by, well, how many do we have here?
86.
No, how many people? How many people do we have here?
Oh.
1, 2, right? So we just divided the number of object or people here. Let's see how many do we have. 43, right?
Ooh.
43. That means the mean or the average height of you and Sarah is 43 inches, right?
Oh.
Similarly, when you have student height, right? You should sum up all these numbers and divide it by the number of students, right? And that's the average, right?
Okay.
So how do we do that? So in programming language, we don't need to write this together. Like that means we need to use 1 plus 1 plus this plus this plus this plus this plus this, and then divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 students here. So in programming language, we have some built-in function. So programming language already have some built-in functions. For example, we have the length. Length tells you length. Okay, when you type LEN, it will automatically pop up length, right? And then we say STU, then it pop up the variable we have, which is the
Student
height.
height.
Underscore height. This is called underscore.
Underscore.
And then we can click here. Let's see what we have here. And when we want to run the R code in RStudio, we just of course we can move the mouse and to here and see run. Oh. And it says student height not found because we don't run this line. We just type the line, the sentence here, but we didn't run it, right? So that's the reason the computer doesn't know, oh, we don't have student height, right? So we don't run. So we have the mouse cursor here, so we can just run. Oh, there's something wrong with this. Let's see what's the problem.
Too much kids?
No, object not interpreted as a factor.
Factor? What's factor?
Okay, the problem is here we were using uppercase C, but instead we should use the lowercase C. So, that's a good way to that's a good thing to encounter errors. when you program, okay?
Oh.
Because when you figure out why you encounter the error, you will have deeper understanding how you should program. For example, here we encounter error and we troubleshooting, we do the troubleshooting, right? And now we know, okay, we have to use lowercase. That also tells you programming language, most programming language is a case sensitive. That means when you use student height, uppercase S, lowercase s is different. So now we can run this. I will tell you another way to run this. You can use Control Enter. Control Enter. Now you see, look at here, this panel. We have 4 panels here, right?
Yeah.
And now when you run this student height, and basically you assign, and also here you can see I use this smaller than sign and this dash, but you can also use equal. In R both works. Okay, so you can run enter. Now both will work. So basically, you tell the computer to do 2 things. One thing, you tell the computer, okay, I want to create a variable which have these many numbers. These numbers are basically student's height, right?
Yeah.
And then you ask the computer, okay, how many, basically the length of this variable. This is called a variable. How many are there in the variable? How many?
10.
10, right? And then you want to know, okay, what's the total? What's in total? How many inches out do we have? You can use sum. Sum means returns the sum. When you put your mouse here, right? You put your mouse here, you can see here it tells you sum returns the sum of all the values present in this argument.
False. Why is there a false? Not true?
The false is another thing. That will be too difficult for you today, but let's us just
It's
focus
not the
on the
true
sum.
False, right?
Okay, so now if we press enter, what's the number do you have? 513.
Yeah.
So that means if you add up all those numbers, you will have, let's see how many do we have. We just change the comma to plus sign.
Backspace.
Shift, you see, shift plus. Shift. We use backspace to delete the comma here, then just shift plus. Oh, we already changed this. Oh. And let's see what happened. Oh, we get exactly the same number, right?
Wow.
So that means what does this sum function do? This is called a function. So this does exactly the same thing here, okay? So you just mentioned when you say sum, there another way to see the help information too. Basically tells you, okay, how to use sum. Oh no. You can use question mark before sum and then enter. And now in this panel, look at this panel.
Yeah.
Here it says sum and then you give dot dot dot. Dot means numeric or complex or logical vectors. So and then it had NA remove equals false. NA remove, NA is basically short for not available. For example, okay, you have 10 students,
Yeah.
but when your teacher measures your height that day, one student didn't come to school because he or she is sick. So that means he or she didn't come for the measurement, right? So that means her data is not available, right?
Oh.
So that way we usually use NA to show that. Okay, that means we have 10 students, but one student's height is not available. Okay,
Okay.
so still we have 10 students, but
Yeah.
one student's height is not available. And when we put this sum, we copy and paste it here, and we can run it again. So we when we do the sum, it will tells you NA not available. Do you know why? Because you have 10 students, but one student's height is not available. How can you know the total, right?
Yeah.
But there's one way you can say, okay, sum function. I don't want have that NA when you do the calculation. When you calculate sum, I want NA remove. RM means remove. And I want basically it's when you by default it's false. That means you don't remove NA. So then we will get NA. But when we can tell, okay, this is true. Oh. When we say it's true, it tells the function, okay, please remove NA when you do the calculation. So let's see what happened. Control, enter. Oh. Control, enter. Now we have 451, right?
Yeah.
So that means when you give this is called an argument
Argument.
or a parameter.
Parameter.
Let's say that's why you see, okay, arguments here. You can provide, this is function, and a function needs you to have some arguments. Okay? So now we say NA dot remove equals true. That means the sum is doing the calculation. It will first remove the NA. It will remove this one. Then calculate the sum of the rest of the values. Okay? So but that is another case you might encounter when you do the data analysis, right? It's all possible. For example, one student is sick and the student didn't come for that measurement, right? It's possible. But let's keep it simple. So let's remove this NA and give it back to, let's say
62.
60. Oh, you have good memory. Okay. Here because we don't have a NA, so it doesn't matter whether we give true or false here. So we can just we can leave it here. We can give it, oh sorry.
What happened?
I think we just type something and give it and just it pop up that window. Okay, anyway, so we can use false because we don't have a NA, so we can give false here. Okay, it already pops up false, so we can just see false. Okay, now we say oh,
What are you gonna write in 3?
3 is just a blank line. When you have blank line, okay, the programming language will just skip that line, okay? And because when we change this NA to 62, we didn't run this, right? So we have to run this first. Okay, then length and sum. Okay, we still have so then what's the mean?
Mean.
The mean also has a function called mean. Okay?
Me.
Mean means,
Me.
and now we have let's say we when we calculate the sum, we're assigned to a variable. Let's say total height.
Total sum
Total height, okay?
Okay.
And now here we say the length of the student, basically the student number. Okay?
Okay.
And now when we calculate the mean, we can easily say, okay, we can use this total height. Oh, sorry, something. Total height. We already have total height. And divided by student number, right?
Yeah.
I think there's something wrong with the student number. Student number. We can just copy it here. Okay, but we didn't. Let's run the whole dataset. Run all the code. We just select use your mouse. You see, left click and select. Okay, and then you can run. You see here, it runs all the code we have. But what is the mean here? So you just write another line just to say mean.
Me.
What's the mean here?
Me.
51.3.
3.
So that means, on average, your classmate's height is 51.3. Okay,
Yeah.
that's the average. But of course, this is just fake data. So we just
What's that on your small computer?
which one?
This one.
Okay, just leave that alone. It's just some notification.
Okay.
But anyway, today you should how to calculate the mean using R, right?
Yeah.
That's cool, right?
Yeah.
And you can also plot the height. Sometimes when you have number, you don't know which one is the higher, which one is the shorter, right? Which one is taller, which one is shorter. But I can just quickly go teach you. Maybe when you have a bar plot, what is a bar plot? A bar plot is basically using some bars to indicate to describe the value, or to show how high you have. You see, when you see this bar graph, you see it's somewhere around here, right? Somewhere around here. But you have very relatively short. This is the shortest, which is the value next to 62. The highest is 62, right?
Yeah.
So you can easily tell which one is the higher, which one is the taller, which one is the
Which
shorter.
one is the 47 thing?
47 is the first one. This one is 47. You see this is called y-axis. This is called
Y-axis.
x-axis. So we have x, y, x, y. You always remember x, y.
Sorry.
On the x-axis, we have 10 students, right?
Yeah.
But later I can show you how to add their name. And then in the y-axis, we have what?
Number.
The height, right? The values of the height.
10 by 10s.
And now we can easily say, okay, this is somewhere around 47, this is 50, or you can see it's exactly up to here, right? This one have 62, so it's a little bit beyond this 60, see? Okay?
Okay.
Of course, you can also draw
Picture?
draw a line somewhere. For example, if you want to, on this you want to say the, I'm not sure whether I can do it today or not, but you can, let's say we want to have a line, x equals, let's say we have an AB line, which is
AB line. What's AB line? AB line?
AB line is the one or more straight lines through the current plot. We want the horizontal line, which is,
Horizontal.
yeah, which equal h. H means horizontal, and we just say h equals mean.
H
Okay.
equals mean.
That means we want to draw a horizontal line. What is horizontal? Basically
Horizontal
this
is
way.
flat.
Flat, right? The vertical is the
Straight.
straight, like this. And I want to draw a horizontal line of the mean, and the mean the 51.3, right?
Yeah.
So it's somewhere around here. Let's see whether we can get that line. Let's see. Let's run. Yeah, we have that line, right?
You.
Cool, right?
Yeah.
Not only this, we can also change the color or the style of the lines. Let's say
But why
we
do
want to
you
use
want
the
the line?
dashed line.
Why do you want the
Okay.
line?
Because sometimes you want to show people, okay, what's the average? What's the mean of this height? Then this tells people, okay, these are the 10 students' height, and this is the mean or the average of the student's height, right? And also, this is black. Sometimes you want it to stand out. You can change the color. When you say change color, you can add one more parameter. Just say, okay,
Color.
color equals,
Pink.
let's say, oh, you like pink?
Yeah.
Okay, let's just say pink. Let's see whether it will work or not. Just control. You see? Becomes pink, right?
Becomes pink.
But this is a little bit, what? This is a little bit
Light.
light. And too thin, right?
Yeah.
You want to be thicker. Let's say, again, you can add what? Add,
Thick.
not like thick, but let's say LWD
What's
equals,
LWD?
that's one line width. You can give it to 3. Let's see how does 3 perform. You see? A little bit thicker, right?
Yeah.
Right?
Yeah.
Right? Or you can make it even thicker. Give a big number. Let's say give it 10. Maybe that's too thick. But let's try. The good thing, you see, that's too thick, right?
Yeah.
But the good thing that when you program, always try different parameter, try different value. Then you can see the effect. Maybe some extreme numbers, you can easily see the effect. Now you see, what does this argument do? This argument changes the width of the line, right? The width of or the thickness of this line.
What's 100 gonna be like?
That's a good suggestion. Let's just try it. It's easy to do, right?
Yeah.
Whoa,
Whoa, that's thick.
that's too thick. That's a reason when you are doing data analysis, pick a reasonable value for the argument. Okay.
Ooh.
So definitely we know, okay, 100 is not a good value, right?
Yeah. How about?
Maybe 3 is good. Okay.
Okay.
Okay. But nothing changed. Do you know why?
Because we didn't run.
No, we
didn't save?
run here.
Oh.
The reason is you already have a thick line here.
Yeah.
And when you put a thinner line, it just goes here, and it would you see, it couldn't, but if let's say change it to a different color, because you can't see it.
How about blue? Is blue
Yeah, we
gonna
can
be
do
good?
blue.
How about blue? Maybe blue will be great. Good.
You see,
picture.
basically you draw multiple lines here, and each one is covering the other one. Since you were drawing a pink one, so the pink is the same number as the background as this one. So you won't see it. But if you draw a blue line, you can see it, right? But the
How do you erase it? Can you erase?
you can't erase it, but you can run this bar plot again, and then it won't have the AB line, the horizontal line, right? And then you can add that line blue, right?
Yeah.
That's good, right?
Yeah.
Okay, what's this line mean?
Dash.
No.
I mean mean.
The mean or the average, right?
Mean.
Okay, good job. High five.
Ah.
Okay, that's what we learned here. Okay.
Okay.
So what is this language called?
Huh? R.
R. Yeah, good. Okay. Next time I can show you more.
Okay.
We can even get some real data from the field. For example, we can get the
What's
leaves
data?
width. Data is like this is the data. This is data set.
Oh.
Data
Graph. A graph. Right?
data basically you can think of that as a set of values of some measurement. For example, the height of a student's height. Let's say the for example your head size. For example, your what else data can you think of? If you use you as an object, what other things can you think I can bear?
Arm.
Yeah, the length of your arm, right?
Yeah.
And what
Legs?
else? The length of your legs. The length of your what? Feet. The length of your feet is a good data, you know,
Why?
because
It's short.
you need to buy shoes, right?
Yeah.
You always need to buy shoes. When you buy shoes, you need to think of your size. You can't buy a baby shoes. Right? That will be too small for you. So
Yeah.
that's why
That's
data
cool.
is important, and your age. The age is also can be used as data, right? That's
So you
a
can find the right clothes.
yes. That's a reason why data is so important. When you go to a shop, right?
Yeah.
You say, "Oh, I want to buy a pajamas."
Yeah.
But which one are you going to buy? You tell the
Six.
yeah. You
Six.
tell them, okay, I'm 6 years old. Basically, you are tell them the data you have. Your year, your age is the data. Is the data, right?
Yeah.
Okay, that's the end. Good job.
Okay.